URL shortener. Why I feel like I have done this before. But anyways, URL shortening service take a long URL string and create short URL version and that redirect to a long URL. Okay. Let's see. So true scope. So I am assuming that the functional requirement is to change something like www dot blah 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 dot something to something shorter like ABCD or something like
Mm-hmm.
that
Mm-hmm.
to make it like way shorter. That is what I'm assuming right now.
Mm-hmm.
Is this assumption correct?
Yeah, that is correct. But do you mean there will be dot before ABCD?
This is just that's it or tiny. I'm like just giving it a
Okay.
like
Uh-huh.
this is just the host URL
Okay. Uh-huh.
ABCDE. And so the functional requirement here, I would say, is the user shall um, shorten their long URLs to a shorter one.
Mm-hmm.
And second thing is user shall use the shortened URL and get the original website or get the original like route to original. Does this look good to you?
Mm-hmm. Yep.
So these are the two functional requirements I could think of. Does it look okay?
Yep. That looks fine.
Okay, so for non-functional requirements, I wonder if okay, so does this service require globally scalability?
We can assume it needs to be globally available.
Okay, so that is like a little bit extension, but initially what I was thinking is availability is probably very important here because um, we want the service to be available. The second thing I am thinking is scalability because as you can see, it might be used by people around the world. The third thing I am thinking here is latency. We can that the user wait for 2 minutes to get one shortened URL. So the latency should also be important here. So these are the three non-functional requirements I could think of right now. Does it look good to you, or is there any specific part that you think I should emphasize on?
No, it looks good to me.
Okay.
Maybe we can discuss more
Um,
if we have time at later.
yes. Okay. So, so to extend a little bit on that part, so available. Never mind. I'll do it when I'm drawing the graph.
Mm-hmm.
So for API part, so the user shall have like that is post request. Um, I'm thinking of a better term, but right now I'm thinking something like this that will take its URL, for example, and this will be something. It will be passing the parameter, and this will return a short URL, which is also a string. Um, in this case, I'm assuming that login or not doesn't matter because the point of this service is more of like changing the URL from long to short. Whoever doing it doesn't really matter in this case. But that's my assumption. Feel free to correct me.
Mm-hmm. Yeah, we can assume that
Okay.
login does not matter. Maybe, I mean, we can have users, but that is not necessary for our system.
Okay. So I want to add another functional requirement here is which user shall get the shortened URL when um, if the long URL is in the system. Get the transformed URL if the uploaded. Does this make sense? So I don't want this long URL keep adding and generating new short URL. If there's already one there, then we just use the one that's in the database. Yeah. Okay. So for API, the first one will include the both first function requirement and second function requirement. As for the third function requirements, to use a short. So this will more likely get let's see. I'm thinking if there's a better way. I can use query string. Wait. Something like this. Does this make sense? So in this case, it's fulfilling the third part of it. With a short URL, I can get the long URL and then route it to it. So these are the API that I have in mind right now. Is there anything that I missed that you want me to add upon?
No, it looks good. We can create URLs and we can get as well. This looks good.
Okay, so the next thing I would like to dive a little bit deeper in the data model schema. Give me 1 second to think about this. So what I would use, okay, there might be a lot of people using it. How am I going latency matters? Sorry, I'm talking to myself, trying to think what if NoSQL database or SQL database works better here. Key value store, okay. So in my opinion, I think both SQL and NoSQL database works good in this scenario. But if I want to make sure that the latency is low enough and there might be hundreds of thousands or even millions of the data, I would probably use a NoSQL database. It could be MongoDB or other database, Cassandra or something. But for a schema, it will be something like ID, which just a unique ID, and long URL. It will be the URL and the short URL, and probably something like date transform or something. The reason I'm putting this is because I think there are a lot of data. There will be very outdated data, and I would like the database to be clean once in a while. That's say whatever is before 30 days. I'm just gonna clean that so that it doesn't swamp the data. So this is what I'm thinking of about this schema. And the reason of NoSQL database here is because I want speed over the consistency, because the consistency probably doesn't matter as much as the latency and availability here. Does this look okay?
Yep. Sounds good.
Okay, so for the schema. Okay, so the next thing is backup envelope. What can you give me a vague number of about how many people per day will be using this system?
Yeah, sure. Maybe we can assume we have 100 million daily active users.
Okay, it's like pretty much kind of a lot of people.
Mm-hmm.
So that's it. Every day it's 86,400. That's rounded up to 100,000 seconds per day. And in this case, the request per second will be 100 million divided by 100,000, which is uh, 1,000, right?
Mm-hmm.
So this will request per second is every second there will be 1,000 requests hitting the server, which is not too bad. To I think one server can handle this request
Mm-hmm.
amount, but just in case, I will also probably replicate the server and load balance them. But this is like a basic number here. And the second thing is, so I'm making an assumption that 1 million it will be distributed all over the day. Do you have like a high level concept of like how many people will be getting getting the long URL from the short URL, and how many about what's the portion of people who will be transforming the long URL?
Sorry, I am not sure about what is the question. Can you say again?
So right now I'm trying to calculate like how every day how many new shortened URL will be generated.
Okay. Mm-hmm.
I can make assumptions. You can give me some number that's in your mind.
No, we can go with some assumption, maybe.
Okay, that's let's say how about like 15 million, half of the not like half, but like let's say if like 15 million new short URL generated,
Yeah, that's fine.
then let's say per column it will be I don't know 200 KB times 15 million. So this will be sorry, I need a calculator for this. Oh wow, this is a lot of zero. 10 times. So this will be something like this. And this, wait, this 16, this will be 10 exabytes. So this is a lot of um, data per day. Please let me, oh wait, it's not 10, it's 50. So it's, uh, oh, actually, no, it's right. So it's 10 exabyte here. This is a lot of data generated every day. So that's why I would like to clean up the database every once in a while. So it's every day new generated. And yeah, so this is the request per second and how much the space it would take for a big bank of envelope. Do you have anything that you want me to add here to emphasize on?
Um, are we certain that it would be something near 10 exabyte?
Sorry, come again.
Yeah, are we certain that it would be near something 10 exabyte?
Yes, unless like there's some calculation wrong here.
Mm-hmm.
That I mean, let me double check. Oh, actually, this is 10 terabyte.
Uh-huh.
Okay, yes. So it will be 10 terabytes per day.
Mm-hmm.
Okay. So cool. If do you have anything that you want me to calculate in the bank of envelope, or I could move forward to the drawing part?
Yeah, we can move forward to the drawing part, I think. And yeah, I mean, this is the amount we are writing, right? And what about the amount we will be reading?
This is the amount that we're writing. The amount we'll be reading. So the amount we'll be reading right now, what I'm thinking is, I used it like 100 million, and everyone would do run for a request, but I can extend it to, let's say, like reading request
Mm-hmm.
would be 100 million. Let's say each of them will do 10 readings,
Mm-hmm.
and divided by, wait 1 second, um, throughout the day, which is 100, like this. Does this make sense?
Mm-hmm.
It will be the request. So it will be 10,000 here.
Mm-hmm.
Oh, not here. 10,000 requests per second for reading.
Uh-huh. Yep, sounds good. Then yeah, we can move on.
Okay, cool. So this, wait, how do I start? 1 second. So that's the O1. Please ignore that part.
Oh, that looks complicated. Oh no, actually,
All right. So I'll,
when I zoomed out, it's nice actually. When I was zoomed in, I could only see the home view model. But yep.
okay. So I draw a box at a like a little bit higher than that original spot. Can you see?
Let me try to find it. Yep, got it.
Okay, cool. So I will probably play around this. This will be one of the what is that area, or let's say I'm North America. This will be one of the. Damn it, I'm like forgetting about what is the terminology of it.
Uh,
So
mm-hmm.
not time zone. Wait. Okay, so this. I am still thinking about terminology, but first let me get started on what I wanted to do. So this will be the user.
Mm-hmm.
This will be user one person. It will go to the DNS and look for the closest. Um, wait. Right. Right. It will go to the DNS. So this will be the DNS and find the closest availability zone. So this might be AV availability 1.
Mm-hmm.
Yeah, so right now I'm in North America. I'm closer to the East Coast, and it might give me New York or something.
Mm-hmm.
And based on this, I can send my request, which I already have, which was the post request of a. Let me take a look. I have a URL, very long URL. Whatever long URL I have here. So this will be a post URL. And I personally like to use 2 layer of the gateway. One is API gateway, another is load balancer, because to me this will clear up a lot of confusion.
Mm-hmm.
So for example, this will be a API gateway, and each of the API gateway will route to different load balancer based on different service. In this case, it might be a shortened URL service. So here I will create a service just for a simple demonstration. It is it will scale on its own. So I'll put 2 of them here.
Mm-hmm.
So in this case, this will be our shortened URL service. So yes, so the route will be something like this. It will go to the API gateway and search for the services looking for, which is a shortened URL service. And this will be a shortened URL load balancer. And this shortened URL load balancer will find the relative service and then do whatever that's needed here. So in this case, the shortened URL service will first go to the database. So this is the database. As mentioned earlier, I want it to be a NoSQL. So here will be NoSQL database, and the schema will be, let me route back to what I wanted. So route back to, it will have ID, long URL, short URL. So this will be something like this. It will be a schema. And what this shortened URL service will do is it will go to the database and then find if this long URL already existed in the database. If so, it will directly return that shortened URL. If not, it will generate a new one and store in the database.
Mm-hmm.
Does it make sense?
Mm-hmm.
Okay. So just to be thorough, I will also add another service, but it will be very similar. This will be the get service of getting the long URL, getting from the short URL, return a long URL. So this will be something like this, which I just copy paste from where we had. And similarly, this will go to the API gateway. And this is a different service here. So there will be another load balancer. This load balancer will control if this load balancer is the uh, route to long URL load balancer. This is just an example of naming. And similarly, the service is auto-scaled, so I will put 2 here, and this will be the route to long URL services. And what this does is also go into the database, and it will find based on the short URL and return a long URL back. So this is high level what I would do, but there's a lot of things to optimize here that I would like to put a lot of focus on. So first of all, what I would do is to do a master slave database. So this will be a master, the left one, and another one will be a slave. Slave will be a read only, and since consistency doesn't really matter here, so the read part of the long URL, it will directly go to the slave database so that it doesn't crowd the master database. So there might be 3. It's just like in general, it's like 1, 3, 5 or something. Wait, this is not pretty. Let me do this a little bit differently. Okay, so something like this. So it will the read part of it will be directly go to the slave database, which is read only, so that it will decouple from the master database. As for the shortened URL service, as I mentioned earlier, because I don't want to crowd the master service, so the read part will also directly be routed here to read. And if it's like, okay, return like nope, return no the URL not existed, then it will do the updating the oh my god, where did it go? Okay. Then it will do the right database part. So this is high level I'm thinking right now. Let me go back to check my spec initially and see if it fulfill whatever I wanted. So for function requirements, I have 3 here, which is shorten the long URL to a shorter one, which is satisfied in this case. As for the second part, is user shall get the transform shorten URL if the uploaded long URL is already in the system, which is also satisfied here. And the third part is user shall use the short URL and route to the original website, which is also covered in the case at the bottom one.
Mm-hmm.
As for the non-functional requirement, the availability. So in this case, I want to elaborate on more. So for DNS, it will find the closest availability. So this will reduce the latency, which is the third part. As for availability, since we have more than one availability zone, so we can think of it as this is AV1 at the top, and there might be AV2 at the bottom. If the AV1 is not working, it will directly route to AV2, so that our availability will also be satisfied here.
Mm-hmm.
As for the scalability, similarly said, we have multiple servers across the world. It will route to relatively closest availability zone, in this case through DNS. And aside from that, what else? So even if like one availability at this the New York is the closest availability to me, but what about our service? Is there a single point of failure? In this case, what I'm seeing right now is probably the API gateway. But API gateway, we can duplicate that. Like this will be also be replicated, and also our load balancer could also be replicated. As for our services, it will be monitored. So there are a few ways that I can monitor it. First of all, API gateway like at least for AWS API gateway, automatically will have a monitor service, which what it will do is to monitor the load balancer here. As for the load balancer part, since it want to scale up and scale down here, we can write some code, maybe like CloudFormation or other services that we could monitor each of the service health and stuff. And if there's a lot of loading coming from the Shortener URL, we will just increase the service, Shortener URL service here, so that our scalability will be fulfilled and latency will be also be committed here. So yeah, that's like high level I'm thinking right now. Is there any part that you would want me to dive a little bit deeper?
I have a couple of questions. Maybe we can focus on something after that. One is, uh, so can you please explain if when the availability zone of any of the availability zone is not working, how would the request rerouting work?
How would the request read out what?
Yeah, for example, the availability zone 1 is not working now. So how the request will be rerouted to availability zone 2?
So I think this will be handled by DNS, which it contain all of the availability status, availability zone status, and it will route to the healthiest part of it. It will first route. It will give you like the one that suits your case the base best.
Okay, makes sense. Nice. And then another question is, since we are having now multiple API gateways, how will the routing work out between them?
So actually, what I'm thinking for API gateway right now is only one. In if I remember correctly, for AWS API gateway, it can take 100 million requests per second. So it's more like master slave. So master one will handle most of it. If they will check in each other, if the service is working. So just to be clear, that's a master and slave. They will echo to master will echo slave, slave will echo a master, but master will also take all the requests and route it to the load balancer. If the slave API gateway that try to find if the master is working, if it's not working, it will directly replace it and duplicate itself to ensure that the API gateway is not off service.
Makes sense. And yep, this is nice. It makes complete sense. Then can you talk about how would you figure out the short URL for a long URL?
So we have this schema will also be replicated in the slave read only databases, and it will directly call like if it find shorten URL. Okay, if it found, then return the long URL here.
But how would you generate the short URL in the first place?
It will be done by the top part of it, the shorten URL service. Yes. So this part is generate.
But can you talk a bit more about the details? Like how do you figure out for a
Oh, okay.
yeah.
So you mean a little bit like how do I come up with like A, B, C, D, E or
Yep,
something?
exactly.
Okay. So what I'm thinking right now is a little bit like, first of all, like whatever URL initially, this doesn't matter, whoever hosted it. But I guess the question is, what about this thing? Like, how do we determine this? Um, what I'm like naively I'm thinking is that this shall be long enough at least. If it's like, let's say it can include character, like um, numeric and alphabetical. So this will mean that something like 52 plus 10. So it's 62. So 62 of whatever many that we want. Let's say this is, I want, let's say I want like 6. So these are the combination that we can have here because I'm like 1, 2, 3, 4 here. Actually, I want 6 of them. So this can at most be like, not at most, it will always be like 6 character here, and we can have this many combination. And so this is initially what I'm thinking. So for the size that we want to make sure that it's working. But I guess the second thing I'm a little bit concerned is that how to ensure that it's safe. So my initial thought will be something like we can randomly generate and see if the shorter URL is there. Like, so what it does is that there will be like a small service just to clarify that this will be like a hash, like shorten string, whatever service. This will only do this thing, like randomly generated, and check if there is already there is not any short URL. There is not the same short URL there. If so, then it will pass back to the service and then upload it. Does this make sense?
Sorry, I missed this shorten string service. What does this do?
So what this does is it first it randomly generate a shortened URL.
Okay.
Second, check in the DB if this URL exists. If not, pass back to the main service, and the main service will put into the master DB. Naively, that's what I'm thinking.
Okay, and okay, and it queries the slave database to get to check if the shorten URL is
Yes.
present or not. So now, could there be any case where we end up multiple short URL for the same long URL?
This will not happen because this part will check. So for the step of shorten URL, this service, let me put it here. So this shorten URL service, what it will do is first it will check if the long URL exists in the slave DB. So this is this arrow up here. The second step, what it will do, if not exist, well, actually, if exist, directly return the shortened URL already there. If not, generate a new one. This is the main step, and this third will go to this part. Go to the shortened URL stream. Yeah, that service. Yep, something like that.
Nice. But since NoSQL database does not have ACID compliance, can we end up in any case where
Mhm,
there is a race condition between multiple URL shortening calls for the same URL? And when we query the
mhm,
database, we get that there is not an entry in the database. But when we insert,
mhm,
actually both of them inserts two entries.
mhm.
Can it
Yep.
happen?
This will this is very likely going to happen because I think that's the trade-off I'm gonna make here.
Mm-hmm.
Um, because the syncing time I don't really want it to be like strong consistency because I don't think it's matter. But the trade-off would be that if the slave database is not synced yet, yet the database has this entry, um, the route here will return like it's not exist and generate a new one. But I think it's manageable. In this case. But what I would optimize is probably put a Redis here in
Mm-hmm.
between everything to try to uh, try to minimize this part, which will be something like this. This will route through this Redis. Sorry, it's a
Mm-hmm.
little bit messy, but the Redis will also cache the latest read and write in this case. So let's say I upload two long URL like almost at the same time, but Redis will cache it and tell me that, oh, I already have this, just return this. So that it
Mm-hmm.
could, first of all, it could reduce the latency. The second part is that it would slightly avoid this from happening, but it could also be that the Redis, like this part got evicted because our Redis is not big enough. But this will reduce the possibility of this to happen.
Okay, yeah, true. I'm just curious, if you use the Redis, what type of writing mechanism would you use for the Redis?
What do you mean? Oh, I see. I think I would do right. Hmm, let me think about it. I was initially thinking about right through. Yes, yes. So okay, that makes sense. All right, I think I know what I will do is more about like right through. So it will be here.
Okay.
Messy, but you get what I mean.
Mm-hmm.
So whenever it generates a URL, it will go to Redis first before generating. So this doesn't exist. So even though it gets from the slave database that it doesn't exist, it will go through Redis, it generate a new one and go through Redis and find out that, oh, wait a minute, there's there. So it would directly return it.
Okay.
This will simplify the method, but it's not optimal because it will still direct the sharing URL service already like ask for Redis first, ask for the slave database in this case. So let me think about this. So what I will probably do is that step one, this will be step one, read from Redis because Redis is definitely faster compared to the our NoSQL database, even though they are both NoSQLs. Then second, if not there, read from slave.
Yeah, I can see how are you deducing to the algorithm, but there is another thing that I'm interested to know is suppose
Mhm.
this is working fine or to the some extent that is acceptable, but another thing that is since we have a very good amount of data, how would you
Mhm.
optimize your database or a structure to feed those?
Okay. So first of all, if there are two parts from it. First is how to structure database. Second is how to clean. There's like two different part of it. I
Mm-hmm.
guess you were asking about the first part.
Mm-hmm.
For the first part, what I would do for a database is probably dividing it to like let's say URL starting from long URL starting from A will go to one part of database.
Okay.
So it will be and give me one second. I'm still thinking. So
Mm-hmm.
what I might do is probably like A B blah 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 or something like that. so that it could split the database to smaller from this point.
Mm-hmm.
But it doesn't mean that it benefits like routing to long URL service. Sure. Okay. Yeah, but I was probably like, so this will be based on long URL
Mm-hmm.
split to different character so that it can be easier. Hmm. Okay, so this will be have an additional part, which is how are we gonna route it back from short URL to long URL, and this will in my opinion, this will require additional hashing service that we have some sort of algorithm that deal with like hash from and back from long URL to short URL, which can easily find our A to Z long URL in this case too. So yeah, in general, I will probably do splitting the database to based on different starting letter or starting letters, so that we can split the database more efficiently and doesn't bother each other.
Yeah, but I did not understood how with hashing we will retrieve the URL.
So the hashing service here is my thought is I don't have like a very specific hashing way that I could think of right now,
Mm-hmm.
but right now is the problem here is that even though I have based on those URLs split to A to Z, and this can help on like generating a shorter URL server because this means that each database wouldn't be blocked by the whole database being blocked. But in this caching service, how am I gonna to transform from shorter URL to long URL? That's another a part of it because right now I'm only based on long URL and split it to like A to Z. So in this case, this hashing service can easily determine based on this short URL, for example, like it can very easily find the long URLs database too. What is the get the starting character. So this is what this hashing service do. It will speed up to find the database that is closest to the that's relevant to this longest database, longest URL.
Okay, so you will keep a reverse map of all of the short URLs
Yes,
to the database.
not like not like all of the short URL, but the hashing service is to transform the short URL, and it will directly find the starting character for a long URL so that it can directly route to that specific database that I store this long URL.
Mm-hmm. And how it will find out from the short URL to the starting character?
So I think this is like a algorithm mechanism. I don't have like a specific thinking right now, but when it's hashing here at when the shortened URL string service here, this will this so in general this service and this service has have this similar hashing way so that hashing to and hashing back from long URL, it will have some sort of mechanism that would directly give me the starting URL.
Mm-hmm.
I don't know if this makes sense.
Mm-hmm. Cool, then I think overall this looks good. So maybe we can wrap it up and go to feedback sharing if that is fine with you.
Sure, that sounds good.
Okay,
Thanks.
cool. Then let's start with I think just a second. I'll just check the note. Yep, I think you did pretty great. You discussed all of the points and you were self-driven, and yeah, you find out like what needs to be done. You did a good high-level design as well. So all of those were really good to me. And also you discussed about availability zones and how it will play with DNS. So
Mhm.
all of these were really nice, I would say. And some things I think that you can still improve is one would be when you discussed about the functional requirements first time, that was time it was a discussion, like you asked for me for my opinion, how does this look like. But when you added this requirement in line 19, that we should get user should get the
Mm-hmm.
same shortened URL, that makes sense.
Mm-hmm.
But since it's a business requirement, maybe it's just better to verify with the interviewer, because it could very much be the requirement that for some reason we need to provide different URLs for the user, maybe to show them different
Got it.
landing pages before redirection and all of those. And apart
Cool.
from that, when you talked about this post API, you pass the long
Mm-hmm.
URL as a parameter, but usually in post we pass everything in the body. So that was a bit of inconsistency. And so
Right.
I'm,
Yes.
yeah, I'm sharing actually everything
Mm-hmm.
that I noticed, so even if it is
Mm-hmm.
small or big. And apart from that, you talked about data schema, that is nice, but when you calculated the back of the envelope, then you just
Mm-hmm.
thought of a ballpark number of 200 kilobyte, but did not really justify why you are
Mm-hmm.
using 200 kilobyte as the data storage.
Mm-hmm.
So that is another thing. Apart from that, if we go to the high level design, these were
Mm-hmm.
nice, the way you have designed, and it was very detailed, so everything in that is nice. The one thing that I felt is maybe you were trying or feeling to avoid the short URL generation part a bit, because when I asked for it, I
Mm-hmm.
did not see very much enthusiasm from your side to discuss on it. But when I tried to
Okay.
dive deep, then you went and said that okay, maybe we will use the randomness. But even then, when
Mm-hmm.
you actually said that I will use 6 characters, you justified a bit that we have 62 characters in here, so to the power 6 is a good number. But that does not actually mean that it will fit our business requirement. So maybe comparing that to the
Mm-hmm.
amount of URLs that we need to create would be a good thing. And
Okay.
apart from that, when you started to discuss about that database partition or sharding thing, then you mentioned based
Mm-hmm.
on long URL that would be fine if we somehow could retrieve the data as well. But since we cannot retrieve the
Mm-hmm.
data based on that, I mean, they're making it work with this system would be a bit hard. And when discussing, actually you were going to the right direction, like actually we would need some kind of hashing to get the short URL.
Mm-hmm.
And then maybe
Mm-hmm.
you could have used the short URLs character to actually do this
Mm-hmm.
partition, because when we query we have the short
Okay.
URL, so that way we can actually find out which partition it belongs to and query. And even if you cannot think of that, or for some reason that is not working or sensible, the
Mm-hmm.
least we can do is we can query all of the partitions and then get the result based on that. So I mean, it's not efficient at all, but it at least works. So that way we
Okay.
can make the system work. But apart from that, I
Mm.
think everything was good.
I think you
And
are right. I probably should base on short URL because reading is probably you wouldn't write the same thing a lot of time, but you will read it.
yeah, true. These are the things that I noticed. Apart from that, I would say you did really good. Everything that you communicated was clear to understand, and yeah, I could really follow through, so it was
Mm.
nice.
Cool. Thank you. I'm actually a little bit concerned about my part when I said that I want NoSQL database and said that
Mm-hmm.
I want a MongoDB, but I didn't elaborate on other NoSQL database, like why MongoDB, why not others. That part I probably should elaborate a little more.
Yeah, true. That you could do, but I mean, usually just justifying why you would go for NoSQL, other than
Mhm.
SQL, is, I mean, fine for the system design interview. But if the interviewer is interested, for sure, you can dive more deep into it.
Okay.
Yep, then thank you so much for your time, and yeah, have a nice day ahead.
Thank you so much for your time too.